Hi everyone, I'm Steve, G8NFZ Golf 8 November Foxtrot Zulu. I've been licensed since April 1st, 1977, good old April Fool. Throughout that time I've been active exclusively on VHF. I have in the past been a committee member and chairman of my local South Down Amateur Radio Society. They recently acquired an Icon IC7300. It quickly became apparent that club operators would need some advice and assistance in using the new rig, and so I assembled a presentation to give them the background they needed. It grew quite large and was delivered as 7 parts over 2 lecture sessions. I've now turned the lectures into 7 videos in the hope that they might assist a wider audience. This is the first of them. I will start with the information that you will most need in order to operate. Later I will go on to elaborate some of the other features of the rig. If you have any questions, please use the number of the video and the relevant slide number that appears at bottom right of each of them as a reference, and I'll try to answer if I can. Let's begin. Here is the basic appearance of the radio. All of the controls are on the front. Available as a file in the details below is a paper facsimile. Shame it doesn't actually work, but it can be scribbled on. As a further aid, I may be able to publish the entire presentation series as an ebook if there is sufficient demand. Among the many things that we do when we are using the radio, the 2 primary ones are frequency control and pressing the transmit button. On the IC7300 we have 28 control methods that set or manage the frequency we're using. I thought we might cover these first. So where can we tune? The IC7300 can receive from 30 kHz to 74.8 MHz in a continuous tuning range. It splits its tuning range into these 13 bands internally, but there are no gaps. These bands are recognized by the system for some controls. I've now added to the diagram the UK amateur band allocations within the tuning range of the radio. There are differences for both the European and American models of the 7300. Shown are 160, 80, 60, 40, 30, 20, 17, 15, 12, 10, 6 and 4 meter bands. They don't give us all that much really. You can only transmit in the amateur bands. The limits are controlled by a diode matrix, any alteration of which will destroy your guarantee, on top of which the bandpass filters aren't designed for use outside the amateur bands, and those who have modded their rig are beginning to regret it. The primary tuning device is the nice, big and very smooth tuning knob. You can tune the entire range of the radio by turning this. You can choose how fast it tunes too. In the centre of the radio we see the screen. It is sensitive to touch. It does not need a vicious poke, and it doesn't have to be a finger, as the screen is not capacitance driven. I use a cotton bud or a very small artist paintbrush to protect the screen, which can easily be scratched, even by fingernails. We can see to the right of the screen that we are in VFO mode and using VFO A. There are 2 VFOs, A and B, and we'll look at those later. Just above the 1 kHz digit is a small white arrowhead. This indicates that tuning will take place at one of the optional kilohertz rates. If we touch the kilohertz figures and hold the contact in place for 1 second, a pop-up menu appears to permit choice. Or you could use an item like this excellent South Down Amateur Radio Society pen, which has a special soft tip for screen use. Let's go ahead and touch and hold the kilohertz digits. The Tuning Step SSB pop-up panel appears. I've enlarged the screen for clarity. We now select the tuning step to use. The chosen step will also be used by the microphone up-down buttons. The symbol at the bottom right is a return command. It accepts the selection and goes back 1 screen. We can also choose to tune by tens of hertz or even single 1 hertz steps by touching the appropriate digits. Let's touch and hold the 2 rightmost digits hundreds and tens of hertz. The 1 Hz digit now appears, and tuning will now change 1 Hz at a time. If this gets a bit tiresome, then just turn the tuning knob a little faster and the rate will automatically speed up. Good for a rapid QSY. Okay, that's the tuning knob and steps. But we really want to be able to change band. The radio does not have band change buttons. Bands are selected using the screen. Touch the megahertz digit. The band stacking register appears. Choose a band by touch. If you hold the touch, then 2 more options for each band appear in turn. Choosing changes frequency, mode and filtration, the preamp and AGC settings to one of those 3 previous settings that were used on that band. The current channel details are saved in the first entry of the appropriate band, overwriting what was previously there. All other settings are unchanged. Note that the Genie button does not produce Will Smith. It cycles between 3 channels that can be anywhere within the radio range. These 3 are best used for the bands for which there are no buttons. In the UK, these are 60 meters, 5 MHz, and 4 meters, 70 MHz bands. You could think of this possibly as working like a primary channel button. It might be the club net, for example, or a regular sched. Touching FIMP allows direct frequency input. Later we will see that it can also select a memorized channel by number. Here's the direct frequency input screen. ENT for enter makes the change, or as on many screens, the return button exits back a level. So now we've turned the knob, selected the steps and chosen a frequency in a band or typed it. Now we get to try something else. There are, as we have said, 2 VFOs, A and B. This button switches between them with a single press. We need to note here that many controls do more than one action. If you press and hold this button, you hear a beep, and the 2 VFOs will both be set to the frequency on screen. This can be useful to set a starting point for assigning a small change in frequency to the other VFO, whether that's A or B. The next option allows us to work on split frequencies. We can work on split frequencies, even cross-band, by setting the 2 VFOs to the 2 channels required and entering split mode. There are 2 ways of doing this. We can call up the frequency input screen again via a touch on the megahertz digit and then the FIMP button. Type in the split we require in kilohertz. If it's down in frequency, then touching the bottom left button, it shows a minus in brackets, sets the split negative. Here we split by 50 kHz. Touch split and the split will be set into whichever is the other VFO. In this case it will be B. On the right hand side the split icon is showing, and below it is shown the frequency that will be used to transmit, in this case 50 kHz up. Remember that the transmit frequency is set in the other VFO. If you're using A, then it will transmit on B, and if you're using B, it will transmit on A. Because of this, the split can be any frequency, including crossband. If you press AB, the roles of the 2 VFOs will be reversed. In a second method, suppose I want to set the transmit frequency on the fly. A DX station is listening 5 to 10 up, so I want to find a spot up there to transmit, hopefully in the clear from anyone else in the pile-up. We've got a button for it. We do not have to leave the receive frequency and lose our tuning. This button places the VFOs in split mode. Your current VFO becomes the receive frequency and the other VFO is used for transmit. Here's the button labelled XFC for transmit frequency check. Press XFC and the radio changes to the transmit frequency VFO only while the button is held, and opens the squelch while you're listening. As an aside, it also disables any noise reduction setting. If you're using split, then the second VFO will show, and you can tune using the tuning knob without disturbing the receive VFO. Here is the screen while the XFC button is held down, and the main tuning dial is used to set the desired transmit frequency. Remember, the squelch is open, so you can hear any other station on the chosen spot. The offset indicator here shows +5 kHz, but the main frequency numbers show this to a 1 Hz accuracy. Having found a clear transmit frequency, let go of XFC. The screen reverts to VFO A and continues to show the transmit frequency set on VFO B. When the DX station calls QRZ, press the transmit button and you'll go out on your chosen split. Magic. In the case of this illustration, the transmit frequency is 5 kHz up, but remember the split can be any frequency, mode, filter, AGC and preamp setting, including crossband. How many ways is that so far that we've looked at? We've looked at the tuning knob, kilohertz steps, the microphone up-down buttons, 10 Hz and 1 Hz steps, band stacking, frequency input, A and B VFOs, manual split, split on the fly, and XFC. That's 10 so far. Here's a button labelled RIT for Receiver Incremental Tuning. This is most useful when someone responds to you just a little off frequency. Don't retune your transmission, instead retune your receiver only. Press RIT and an additional numeric display appears. And here's RIT showing a 100 Hz negative setting. The offset is adjusted using the multi-function knob. This knob will feature heavily as we go on because it does what it says on the tin. Lots of functions. If you press and hold the RIT button, the adjustment is applied to the current channel. Here we've dropped frequency down by the 100 Hz we had set, and the RIT number has cleared. Press RIT again to remove the offset display. Here's a button labelled Delta TX for Delta Transmit. Delta is the Greek letter used in algebra to indicate a small change. They used this to avoid using the term transmitter incremental tuning. Press Delta TX and just as for RIT, the additional numeric display appears. This shows Delta Transmit set up. The transmitter will transmit 100 Hz higher. If you press and hold the Delta TX button, then the frequency adjustment is applied to the channel and the Delta TX resetting returns to 0. Just like that. As you see, we've moved everything back up by 100 Hz. Delta Transmit can equally well be set to go lower in frequency. The amount in both cases is set using the multifunction knob, just as before, and can, in both cases, be up to 10 kHz up or down as required. And just in case you wondered, yes, you can have both RIT and Delta TX on at the same time. In this case, you will both receive and transmit 100 Hz lower. No idea why you might do it, but you can. Both RIT and Delta TX use the same offset, so you can't RIT by one amount and Delta TX by another. We're now up to 15 ways of managing frequency incidentally. ICOM had a button left over and so invented a job for it. This is the clear button. It clears the RIT and Delta TX contents to 0, but only if one of them is active, so it's largely unnecessary. And so to our next control. Just below the clear button is one labelled VM for VFO memory. The radio has 101 memories. It stores them internally, even with the power off, and the settings can be saved to an SD card, which we'll get to later. 2 memories are reserved for the low and high ends of a range that can later be used for scanning for activity. Typically, these will be set for the extreme ends of the radio range. The other 99 memories are at your discretion. For now, I'll just illustrate their use. Later, we'll see how they're set. Just below the VFO A indicator is a number. This is the number of the currently selected memory. If it says blank underneath the number, then it's an empty memory. But the number means nothing if you're using a VFO. The up and down arrow keys choose a memory number, but still nothing happens if you're in VFO mode. The selected memory only controls the radio in memory mode, which we can choose with the VM button. If you press and hold the VM button in VFO mode, nothing happens. If you do it in memory mode, the VFO gets set to the chosen memory channel, unless it's empty, blank, in which case nothing happens. Here we've switched to memory mode. On my rig, memory 1 is the middle of top band. It's set to LSB, IF filter number 1, there are 3 to choose from, AGC is set slow, and the preamp's off. I've named the memory top band. The name of the memory appears here above the frequency digits, but some screens don't allow the name to show. Then we have to rely on recognizing the frequency or knowing its memory number. Whilst this is inconvenient, when we see later how busy a screen can get, it's not too bad a loss. The VFO remembers the channel it was on when we switch to memory, and a switch back will return there. As I said, if you press and hold the VM button, the memory on screen will be copied to the VFO. The most important feature, however, is that recalling a memory doesn't fix the frequency. Once a memory is on screen, the tuning knob and most other frequency altering controls will work just as if you were using a VFO. Retuning does not overwrite the memory channel either. In fact, a quick up-down on the memory buttons will put you straight back to the remembered channel. What's more, when in memory mode, the up-down buttons on the microphone step through the memories rather than changing the frequency in steps. All a little bit whizzy. You can touch the word VFO, or in memory mode the word memo, on screen, and this pop-up appears. The memory button is highlighted here because we came from memory mode. If we touch VFO, we'll go back to VFO operation. And if we came here from VFO, we can touch memory to switch that way too. If we touch and hold MCLR, the memory will be cleared. There's no need whatsoever to do that because a new channel can be written to the selected memory by touch and hold on MW, memory write, and it overwrites anyway. Select is special. It does not, as you might imagine, choose the channel. Instead, it assigns it to one of 3 groups of channels that can be chosen to be scanned. Each touch of select moves the option to scan group 1, 2, 3, or back to none. Scanning comes up later. This screen shows that I've assigned memory 1 to scan group 1, as shown by the little numbered star under the memory number. If you happen to know the number of the memory you wish to use, then you don't have to scroll through all the rest. Use the megahertz digit and FIMP route to the manual input screen, enter the memory number, here I've used memory 10, and touch Memo. The radio will jump directly to your chosen memory channel. Back to the front panel now for another button. This is the memory pad button. If I happen to find a particular frequency when tuning, but I don't want to permanently store it, or if all the memories are full, I can store it temporarily in what is called the memory pad, a sort of electronic scribbling area. So, for example, that amateur you hear in QSO and want to come back to after tuning around to give her a call when she's clear. Press and hold MPAD and a double beep confirms you've saved the frequency. Note that MPAD does not save splits. You can choose to have 5 entries in your MPAD or 10. Having 10 doesn't appear to restrict any other feature, so I'm not sure why you might choose 5. When you add the 11th, you push the oldest one off the end. To recall an MPAD entry, just push MPAD and it will cycle through your saved channels with each press. It also remembers the channel you started from, so you can cycle round and back to where you were. Usefully, that remembered channel doesn't take up an MPAD space. Just as for memories themselves, recalling an MPAD frequency doesn't fix it. You can tune away with other controls. The radio has facilities to manage the MPAD entries. The details for that come later. There's another little button, especially for the CW operators, who I expressed a hope will get to exercise the club rig from time to time. Here it is, hiding in the corner. It's called Auto Tune, and it's nothing to do with the antenna tuning facility of the radio. CW operators can choose their preferred audio pitch for listening to CW. Tune close to a CW signal and press Auto Tune, and the rig will net the VFO exactly to the signal at the audio frequency that has been chosen. The Auto Tune icon appears briefly while tuning is happening. It disappears when it's settled. This is a really smart feature. You will be dropped exactly onto the received frequency ready to key up. No, it does not work for single sideband. And if you press Auto Tune and this happens, you've got a problem. I stole this joke from Facebook. The last little button in this section is labelled Speech and has an icon of a key on it. It's called Speech Lock. In its default setting, a press will call up a nice lady telling you your mode, frequency and S-meter reading. Press and hold and the tuning dial will lock. Optionally, it can lock the entire panel. If you find that nothing works, try the lock button before you panic. These screens show the pop-up that appears while the lock is being applied and removed, and while the lock is in force there's a small key icon above the unit hertz digit. So far we've covered 24 of the controls that affect frequency, and in the process dealt with most of the functions of the buttons and knobs up at the right hand end of the front panel, although the multifunction knob reappears many more times. If you have questions, keep a note of them. There are 6 more videos and I might well show the answer in one of those. Have a look now at part 2. For the moment, 73 G8NFZ Golf 8 November Foxtrot Zulu. Off and clear.